Alright guys, so we learned a little bit about math class yesterday, Java's math class, and so today what we're going to try to do is write some of these methods that are in this file right here. So math class methods, go ahead and click on that. Okay, and I'm going to jump down to number 5, electron velocity. Okay, and we're going to walk through how to do this program so that you should be able to handle any of the other ones. This one's pretty complex. Okay, so hopefully you got BlueJ open already. If not, go ahead and pause the video and run BlueJ. We're going to make a new class. We're going to call it Math Class Methods. Click OK. Okay, we're going to go in there, and yours will look like this. And so then we're going to make a new method called public static void electron velocity. Okay, so we're going to use a scanner. So sorry about that. We're going to import java.util.scanner so that down here we can go ahead and make our scanner object. That's going to input for the user, and then we can go ahead and close that scanner right away. So guys, if I'm ever going faster than you want to go on this video, just go ahead and pause it, and then you can catch up and then start it again when you're ready to go. Okay, so let's go ahead and take a look at what we have over here. So this is that we're trying to find the time in seconds that it takes an electron to move between the cathode and anode of a cylindrical rectifier tube, which is governed by this equation. So time equals all this stuff. Okay. So there's a lot there, so we're going to try to unpack that, but it tells us what these variables are. So M is the mass of an electron, Q is the charge of an electron, V is the applied voltage in volts, small r is the radius of the inner tube, big R is the radius of the outer tube, Z is the natural log of big R divided by small r. And then we're asked to write a program that prompts the user for V, which is the applied voltage, R, the inner tube radius, and R, the outer tube radius, and then computes the travel time. Okay? So, let's get started. We're going to ask the user to enter the voltage. And then we're going to go ahead and get that value. So I'm just going to call it capital V because that's what it's called on the program descriptor. Usually we would use a lowercase v, but we have like a small r and a big R, so I'm just going to go ahead and use the v like they have on there. And then we're going to use input, that's what we named our scanner, to go ahead and get the next double. Okay. So the next thing that we need to do here is get little r and big R. Little r stands for the inner tube radius. So like we've talked about before, let's go ahead and copy and then paste. We're going to say enter the diameter of the inner tube. Is it diameter or is it radius? Enter the radius, sorry about that. Radius of the inner tube, and we're going to call that little r. And then we're going to copy that guy and say that we also want the radius of the outer tube, which we're going to call big R. Okay, so now we have our 3 inputs that we need. Now we're going to go ahead and figure out some of this other stuff. So in order to compute this stuff, I need M. M is the mass of an electron, which I guess is 9.1083 times 10 to the negative 31. Okay, so we're going to go double M equals, and then 9.1083, right? And then we want it to be times 10 to the negative, so times 10 we can do with E, negative 31. All right. And so similarly, we're going to do something with Q, the charge of an electron, 1.60206. Okay. 1.6026, is that right? I think I screwed that up. 60206. 60206. And again, it's times 10 to the something, so we're going to use E for that times 10 to the negative 19. All right. And so then the next thing that we're going to do, right, is we've already asked for these values, so let's go ahead and figure out what Z is. Z is the natural log of big R divided by small r. Z is the natural log, and if you look at your list of methods, which is in here, math class handout, okay, so we can see that returns the natural logarithm is down here, so that's math.log. So I'm going to go ahead and go math.log, and then in here we're going to go r divided by r. Okay, so you don't need all those spaces in there. I'm just doing that so you can read it a little bit better. Okay, so let's get back to this guy. All right, so that comes from that expression right there, and now we're finally going to use that inside of this expression to figure out what time is. All right, so double time equals, and if we look at this, the first thing that we got to do is find the square root of something. So we're going to go ahead and go math.sqrt. Okay, inside of that parentheses, we're going to do 2 times m divided by q times v. So 2 times m, and then divide that by q times v. So that should just work out like that, but if you're worried about it doing like this division before this multiplication or whatever, you can put these in parentheses just to make sure that you're going to divide by that whole quantity. It'll do this before it does the division, so then if you want to make sure it does q times v first, just go ahead and put it in parentheses like that. Okay, so then the next thing is we're going to multiply that result, the square root result, times little r, and then hopefully you saw that it's also times z, okay? So rz times all the stuff that's in this set of parentheses right here. So times parentheses, and then inside the parentheses we're doing 1 plus, okay? And now we're going z divided by 3 plus z squared divided by 10. Now it's something like z squared. I just go ahead and do z times z. It just is a little bit faster for me. If it's something like the next thing, which is z to the third divided by 42, I might do z times z times z, but we can also do math.pow. That's one of the things we talked about yesterday. That's going to be z comma 3 for z to the third, and we want to take that divided by, I think it's 42, all right? And I just realized something that I'm doing as I'm going through this is I kind of mixed up my capital Z and my lowercase z. So since we used capital Z right here, we're going to go ahead and use capital Z all the way through there. So this has to be a capital Z, this has to be a capital Z, that has to be a capital Z, and that has to be a capital Z. And then we got one more piece that we're going to add onto this. This is getting pretty long, but hopefully you can just kind of rewind and fast forward and get to where you need to be here. So we want to do math.pow again, and that's going to be z to the fourth, and z to the fourth is divided by 216. Okay, so all of that is in this set of parentheses right here. So that right there that I'm highlighting is this right here. All right, and so at the end of this, we can just go ahead and put a semicolon, and that should give us all of time. So it's kind of a long one. Like I said, that's why I did it for you guys. But the next thing that we want to do then is just go ahead and output the time. So let's go ahead and put a system.out.println and say something like the time it takes so the time the electron took was, and then we're going to go ahead and add on the time, and then I'll just go ahead and add on seconds. Okay. So hopefully that makes some sense for you, and then we're going to go ahead and we want to run that. So I'm going to go here, okay, compile this, and now we can go ahead and run Electron Velocity. Enter the voltage. Guys, I really don't know what a good voltage is here. So let's just say that we're running this thing at 80 volts, okay? Enter the radius of the inner tube. So I'm going to say that that is like 0.25 of a meter. And let's say that the outer tube is, let's say, 5 meters, okay? The time the electron took was 1.10 times 10 to the negative 6. So that's very close seconds. So that's almost 0 seconds, but that's how fast electrons move. So if you do yours, then you should be able to get that result as well.